Alright, time for another DraftPhysics.com, debatephysics.com also, but we can't find anybody to show up for a debate. Can't have one in response videos, can't even have one in comments, frankly. Nobody will stay on the subject. It's just a bunch of my side is right. It is kind of a war. It's kind of funny because, yeah, this joemyheck guy is a veteran. You know, somebody's got to do it and all that kind of stuff, but I can't say I'm too thrilled with the wars we've been in. But whatever. I admire courage. Don't like bullies much, though. Anyway, try to just keep that out of the subject, right? See, this is the problem. You can't keep anything out of the subject. Can't argue physics without arguing a whole pile of other crap. But anyway, so this guy has... yeah, there he is. Okay, he's got a kind of a channel. It's a little strange. Anyway, he used to make full-length videos, but I guess he just makes shorts now. But he's made a couple of videos that touch on the Newton's Cradle. Okay, and so that is an interesting subject, and I think this he hung some. Alright, so this video has this big giant one made out of bowling balls. It doesn't really work that well, frankly. I mean, it doesn't do everything, you know, you're kind of like, oh, you know, is that it? I mean, it doesn't, like, impress the hell out of you. But anyway, you know, maybe some springs between them. I don't know, maybe they're not elastic enough, a little bit too rubbery or something, blah, blah, blah. But it doesn't really matter. Okay, the subject is that kind of obviously he's doing the 2 to 3 thing, but you do the 1 thing and 3 things. So if he had 4 balls and he had moved 1 out, right? So this is the dilemma, Joe. If you watch this video, you know, I could do this, right? You can see that, yeah. So I do this 1 thing. Let's just stop those from moving. And only 1 goes out. Now, technically, okay, and it goes out with the same momentum that I started with. You know, a little bit less, of course, but, you know, if I glued all 3 of those together, okay, so it was a 3 mass, physics says this goes in, and those 3 of them leave with 50% more momentum. So if I went in with 100 momentum, these 3 will leave with 150, and the 1 will come back with 50. And that's the dilemma. So this is a classic experiment. They do this with air carts and their little rolly wheel carts. I mean, it's a little high school kind of experiment. And I've always found it can't be. I mean, you know, reality doesn't work that way. So you know, I'll illustrate it here on the board more clearly. But, I mean, it clearly just doesn't make much sense, and so it would be nice if somebody opined on the subject and could state, you know, with some sort of authority, that they understand exactly how it's possible to make free momentum, because that's what the experiment basically does. So you start with this is a 3 mass, and this is a 1 mass. You put 100 momentum in, okay, and they hit each other. And 150 flies out this way. That's what it does. 150 goes this way. The 3 moves with half the speed of the original thing. So they both go half the speed, is what physics says. Now I say it's only a quarter of the speed, obviously, because you have to conserve the momentum. So 3/4, okay, plus 1/4 would make perfect sense. So they do leave at the same velocity, but the velocity is 1/4, not 1/2. And that conserves the total momentum. You had 100 in, you have now 100, 75 going here, and 25 going that way. Obviously, the thing that really doesn't make any sense is if this is actually 150 and this is actually 50. If I have a car crash between that, I'm not going to get just 100 back out, and that's what they say happens. So 150 crashes into 50, and you only get 100 out. That's it, just this. Just back what you started with. So you end up right back where you started. So you make free momentum, and especially you make free momentum in one direction. You go from 100 in this direction to 150 in this direction.
and and then you have the extra 50 the other way, and then you end up back at 100 again. And I say, that just can't, there's no possible way momentum can do that, because momentum actually has to be conserved. There's not extra momentum anywhere. Now, I could talk about ballistic pendulums and bullets, and the fact that, you're a military guy, so you should be able to appreciate that. They say basically, the bullet, you can fire it into the ballistic pendulum, a big heavy thing. You fire the bullet in, and you conserve like 97% of the momentum. Sure, you lose some of it to the clay moving around, but you take in the bullet and you get your momentum, and you're conserved 97%. And they concede that you lose 99% of the bullet's energy is gone. So you start with like whatever, a bullet that can do 5,000 watts of work. It plows into the ballistic pendulum, conserves 97% of the momentum, and loses 5,000 watts of energy. Just gone. No explanation. Again, Newton's third law, equal and opposite reaction. How is a gun showing equal and opposite reaction, right? I mean, I fire the gun, 2,000 joules or 2,000 watts of energy flies out this end, and the gun moves away with 2 watts. I mean, how is that? How is that anywhere near a third law thing? So, hopefully you'll be willing to opine on this subject. Now, obviously, my contention is 1/2 mv squared. The theory of kinetic energy is a fable. It was just made up. It was never true, will never be true. It started with the axiom that dropping 4 pounds 1 foot is the same as dropping 1 pound 4 feet. That somehow you get 4 units of power because you went 4 units of distance when, kind of obviously you're only in the gravity twice as long. I mean, maybe you were in the Air Force or something, you had to do that flying thing, and well, anyway, the gravity's about time. It's not about distance. How long you're in gravity. Like physics basically says you can't go across thin ice because gravity's always the same. It's always the same pressure. You can never put less pressure on a surface because friction is always linear. When, of course, I'm arguing now, when you're going fast, very little friction. Going slow, lots of friction. Bowling balls. You have bowling balls in the video. Okay, so the physics says if you can have a 16-pound ball going 8 miles an hour, or you could choose an 8-pound ball and throw it 16 miles an hour. And physics says the 8-pound ball going 16 miles an hour has twice as much energy. That means it can it can basically knock down 2 sets of pins. It can knock the pins down twice as fast. It can do whatever. It's twice as much. And yet no bowler uses an 8-pound ball. They don't even use a 10-pound ball. They don't even use a 12-pound ball. They don't take advantage of any of the advantage and end up using 16-pound balls. And so there clearly can't be any advantage to using the lighter ball and throwing it faster, because if there was any advantage, they would have found it. So none of that physics makes any sense. I spent years now on the internet trying to get somebody to talk about this and fix all those paradoxes. And a spaceship, another simple paradox. Maybe you did some space stuff. Who knows? NASA. Who knows? You throw again, back to the bullet in the gun, we could just say. You throw the bullet out one side, okay, 1 atom going 1,000 miles an hour, and then you throw 1,000 atoms going 1 mile an hour out the other side of your spaceship, and your spaceship doesn't turn. You just threw 1,000 times more energy out one side, 1,000 watts, and then you only threw 1 watt out the other side, and the ship doesn't turn? So again, where's there any appreciation for Newton's laws or even just plain common sense? How could I make 1,000 units of energy go out without that equal and opposite reaction? If I have 1,000 watts going that way, I have to have the 1,000 watts going the other way, kind of trick. And I just can't, I can't break those rules. So what's the story? What do you think? Will you talk about it? But see, all somebody has to do is start talking about it, and then a bunch of people will show up with all kinds of arguments, and maybe one of them will actually be able to point to a piece of evidence, good evidence. Now, the Mythbusters have car crashes. You know, they smash a car at 50 miles an hour and it crashes this much, and then they smash it into the wall at 100 miles an hour and it crushes exactly twice as much, indicating that there's no quadratic increase. You know, that's just twice the velocity, twice the destruction, which seems like plenty. Because that's what physics says. Physics says, like to spin a motor, it would take 100 times more fuel to spin it 10 times faster. So just to go 10 times faster, I have to put in 100 times more fuel. That doesn't make any sense. Come on, it doesn't make any sense. You know it, right? If you're going 50 miles an hour on the highway, you're not using 25 times more gas than when you were at 10 miles an hour. It's just ridiculous. And you can't get anybody to fess up that that stuff just doesn't make any sense. This should be resolvable. There should be some really secure way to say, look, here's the beyond reasonable doubt evidence. Not a bunch of mushy evidence, but beyond reasonable doubt evidence. I mean, these questions don't seem like something that should stay out in the mystical vapor somewhere. There should be hard facts to prove that if this free momentum thing is possible. I mean, another thing they say, okay, I mean, it's just the fact they say this, you know, and it's, yeah, come on. This doesn't seem ridiculous to you? You put this weight on, so that's 1 unit. I'll let you see the scale, not that it's going to help you any, but you put this weight on, okay, and that's 1 unit of energy. And then I do exactly the same motion, exactly the same. And I slide that one on, and now I have 4 units of energy. That's what 1/2 mv squared says. Now, how can anybody believe that? How could 2 units of one motion create 4 units of action, or potential, or energy? It's just not possible. All right, so it's the best I can do to say hi. I love, you know, interesting videos, especially you're, you know, taking the screen off one of the really old projection TVs, because they have a Fresnel lens on them, and it really is amazing how much you can burn. I have one that's about 10 inches. That wasn't quite enough, though, so I wanted to seal the cracks in my driveway with it, but yeah, it just didn't get hot enough. So anyway, I'll try again. Maybe I can enhance it somehow. Anyway, so till the next time and such and so forth and whatnot. That's probably enough, right? So I'll probably, you know, I'll leave a comment saying response video on this video, and we'll see, you know, maybe get blocked in 15 seconds, but whatever. I can only do my part. I think I'm being friendly and nice enough. You know, somebody should be willing to respond with something rational, something. But we'll see. So yeah, enough. Till the next time and such and so forth and whatnot. Well, I could talk. I mean, I saw that you buried a cactus. I thought that was kind of funny. You know, in really hard ground. You know, living in wherever you are, the desert or whatever. And but yeah, that I say, okay, why would, you know, I didn't watch the video, so I was just speculating in my own head. Why would you bury a cactus? I mean, it's dead, but you know. But then I thought about it. And I said, yeah, you know, there are some things that decompose badly. You know, it's almost like there's some plants, they end up decomposing like they were animal flesh, and it's, you know, it's not like maggots show up, but it's pretty bad. I mean, they get pretty slimy and disgusting. I noticed that when I was composting some things. They just don't compost. They just turn into slime. You know, and it's like, ew. So maybe that's why he buried it. But it might just be because somebody might bang into it and get a bunch of, you know, that's, some of these cactuses are nasty. I have some little cactuses, and even they're nasty. You know, you just brush up against it, and you end up with all these little micro, fine, tiny little frickin' annoying little, like, yeah, well, thorns, you know. You know, and you can't get them out, and you know your body's going to have to absorb them, and they're full of some sort of toxins, and they, you know, it gets kind of itchy and crappy, and so yeah, cactuses really are, you know,
it is kind of surprising that something living in such a shitty environment would have to have such a monstrous defense mechanism. Because, I mean, how much is walking around? I mean, there, there's not that much interested. But I guess it's the desperation thing. Anything that is walking around is pretty desperate and take a bite out of anything. Anything green. But evolution is, you can spend your whole life, thinking about how everything got shaped the way it is. So anyway, till the next time, such and so forth and whatnot. This is probably the last friendly video I'll ever make, because I'm sick of being a nice guy and getting nowhere. So if I want to get nowhere, I might as well be a shitty guy and do it. All right. So till then and such.